All right, let's talk about how to take a decimal that's repeating and write it as a fraction. We know that all repeating decimals are rational numbers, which means they can be written as a ratio or a fraction. And this is the process for how we do that. So I'm going to make up a number right now. I'm going to make it 23.478. This might be really ugly. Who knows? We're going to repeat. We're going to have those last three digits repeating. So in other words, that's 23.4782782 and so on. And we're going to write this repeating decimal as a fraction. So step one says we write the equation x equals the repeating decimal. So here we go. X equals, and in fact, I've already got it written up there, so I'm just going to write an x equals in front. But it says to repeat the digits a bit instead of using bar notation. So I'm just going to ignore that bar, and I'm just going to repeat those three numbers for a bit. All right, step two, it says multiply both sides of the equation by a power of 10. But which one? Should it be 10 or 100 or 1,000? Well, the way we can decide which is to look at how many digits are repeating. So I see the 7, the 8, and the 2 are repeating. That's 3 digits. So I'm going to raise 10 to that power of 3. 10 to the third power, 10 cubed, is 1,000. So I know that's correct because 1,000 has 3 zeros, so that's 10 to the third power. So I'm going to go ahead and multiply both sides by 1,000. So I'm going to do times 1,000, but I'm going to do times as a dot, not to be confused with an X. Here, I'll do it this way. Times 1,000, and this one times 1,000. Okay. So the left side's going to be easy. I'm just going to get 1,000x. And on the right side here, when I multiply by 1,000, I can move the decimal place 3 places. So I'm going to move it 1, 2, 3. It's going to end up right there. So my answer is going to be 2, 3, 4, 7, 8, period. And then I'm going to have 278, 278, etc. So here we go. 278, 278, and so on. All right, that is step 2. Step 3 says subtract the original equation from step 1. That's what's written in blue there, so I'll use blue again, from what I just got in step 2. So step 2, that's red minus blue, and I'm going to make sure to line up the decimals. So on the left-hand side, I have x here, so I'm just going to subtract x from the left-hand side here. But on the right-hand side, I have all this stuff here, and I'm going to go ahead and subtract that from the right. I'm going to do minus, and my decimal originally was right here, so I'm going to make sure the 23 decimal, and that these are perfectly lined up here, they match. And then I'm going to have my 4, 7, 8, 2, 7, 8, 2, etc. Those are all going to really line up there. So that is the beginning of step 3. Now I have to actually do the subtraction. The left side's going to be easy. It's just going to be 999. But the right side, something interesting is going to happen. I'm noticing, because I was really careful about how I lined up my digits here, that this 8 minus 8 is just 0. I don't even have to write the 0. I could. But 7 minus 7 is also 0. 2 minus 2 is also 0. 8 minus 8 is 0. These match, so those subtract to 0. Now, here's where I really got to really start paying attention. At this point, I'm going to think, what is 2 minus 4? And let's not say 2, because it's not. 2 is not enough to subtract 4, so we have to borrow. I can borrow 1 from there and put it over here. 12 minus 4 is 8. Decimals are going to stay lined up. 7 minus 3 is 4, 5, and then 4 minus nothing is just 4, 3, 2. All right, I have completed step 3. I subtracted, and now I'm on to step 4. I'm going to solve for x. So when we solve for something, what we're actually doing is we're isolating it. So right now, x is being multiplied by 999. I'm going to divide it. Multiplication and division are inverse operations. So we're going to end up getting just x on the left-hand side, which is exactly what I wanted. And on the right, we have this funky fraction here. The thing is, what I want to do in step 5 is to write the x as a fraction with integers in the numerator and the denominator. And this numerator here is not an integer, it is a decimal. So what can I do to make it an integer? Well, how about we just multiply it by 10? That'll move that decimal place on over, right? So if we move this over, and then we're also going to have to multiply this decimal place, move it over by 1 when we multiply by 10. So I'm going to get 2, 3, 4, 5, 4, 8 divided by 9,990. And that is going to be a fabulous answer. The last step is to reduce, if possible.